Welcome to another segment of High School Geometry with Netz and Weigel. This is Mrs. Netz.
And this is Mrs. Michael.
And today we are looking at 5.5 coordinate proofs. What are we going to be learning? Well, by the end of the lesson, you will be able to use given information concerning the lengths of sides and or measures of angles on a coordinate plane to determine where the final point must lie. So it's sort of like I give you a square and I give you 3 points on the square and then I go, hey, find the fourth. That's what you're going to be doing today.
So you have to know those properties again.
You absolutely do. So why do you need to know this? Well, understanding how to draw polygons on a coordinate plane given coordinates for the vertices by using coordinates to find the length of a side joining points is going to be very important to understanding a little bit more about your different polygons and their properties. So how will you know it? Well, you'll know you've mastered it when you can take a given set of points and your knowledge of properties of a polygon and you can locate missing points on a coordinate plane.
So let's go ahead and get this show on the road. So I started out by doing with numbers. The next problem is going to be pretty much the same problem but with letters, because remember, if you can apply the pattern and the property, you shouldn't need to know the numbers. As was pointed out to me earlier, the farther you go in math, the less you actually use numbers.
Yeah, it's kind of funny because today when Mrs. Weichel came over and we started sitting recording videos, we invited in my little, he's not little,
Your little brainiac son.
my son, and he came in and he showed us some pretty upper level math and pointed out to us that the higher you go in math, it really has little to nothing to do with numbers. It's a letters game.
Yep. So, okay, so what we're going to do here is we're given this square. So you're told that this shape is in fact a square, and you can use the properties of the square then to answer the question. The question is, what are the coordinates? Where are all the coordinates on this picture? So knowing the properties of a square, and if you know the coordinate plane, you know that this is the origin, and you know the coordinates of that origin. You can see that the bottom of the square is going along the x-axis, meaning it is horizontal. You know going up along the y-axis is going to be vertical. Because this is a square, you know these are right angles, and you know that these are four congruent sides. So therefore, here's your answer. You know that these are all 7, these are vertical, these are horizontal. So therefore here, this point, let me get my highlighter going again. This point right here must be at 0, 0, because that's the origin on the coordinate plane. Then I just was given that I went up 7, so if all I did was go up 7, this coordinate must be at 0, 7. Going this way, all I did was go to the right 7, so therefore point H must be at 7, 0. Point G is, again, kind of like a multiplication chart. You went right 7, up 7, so therefore G must be at 7, 7.
Okay, Mrs. Weichel, I'm going to toss something at you you're not expecting.
Uh-oh.
Yep. Do you remember when we had to construct with our compass the cube?
I do.
This is actually kind of reminding me of this. So, like, if we busted out our compass right now, and if we were to construct our cube, we basically have perpendicular lines here, and the perpendicular lines are our x and y axis. Agreed?
Correct.
Right. So then we would use our compass to measure off some distance.
Right.
So we would measure off some distance from 0, 0 to 7, 0, or h. And then we would use our compass to measure up the y-axis to go the same distance.
Yep.
But then we would slide our compass
That
over.
means you actually, at that point, already know 3 vertices.
Yes.
Is the starting one, and then where H and where 0, 7 is.
Right. And then if you slide your compass over on the x-axis, you can use your compass to measure how far up you would have to go, and you can make a little mark. And then if you slid your compass up on the y-axis and made a little mark over to the right as to where you were needing to go, you would then have this little X marks the spot and you could connect them all. This is so similar to the cube thing.
It is very similar. All right, so the next problem, you'll notice that the picture is very similar, but this time we don't know how high up we went. But we do know that in this picture that from 0, 0, we were told that this side length was 7. Notice the ordered pair is 0, 7. So in this problem, even though we don't know how long our side is, we know that we went from the origin up to this point, which is at 0a. So because we went from 0 up to a, we can make the conclusion that this side length must be a. And if this is a square, then all 4 sides must be
A. Now we know that it went up A because we know all of our coordinates are X and Y. And Y is talking about our values that go up and down. X is talking about our values that go right and left. So in this case, we know that A is our Y value. So we know we went up some A value, whatever A may be.
And what A is irrelevant, but we know that this is a square. So therefore we can apply that all 4 sides must be A. So from 0 we can go to the right. A distance, however far that is irrelevant because we know H would be at A0 whatever A is, just like we did with the 7s. To get to point G, we know we'd go right A and up A, just like we did with the 7s in the previous problem.
Very cool. That was not so bad.
No. A question that I've seen pop up on, I don't remember where I saw it actually, was given no letters, given no numbers, you could really place this anywhere you want. The best place to center around is always the origin, or to place one of your vertices at the origin, because you know the origin is at 0, 0, and that's a very powerful point to include when doing problems like this. So if you're asked to graph a square, and you're not told where to put it, I would make sure one vertex is at the origin.
That's pretty helpful.
All right, so I went ahead and did the next one again with numbers, since that's what you guys are more familiar with. So this problem, you're given that you have a rectangle, and the question is asking you for what would the coordinates of M be. So again, you guys need to know your properties of a rectangle, and you need to understand the placement on the coordinate plane. Again, as I just said a few seconds ago, I have one of my vertices at 0, 0, because that's 0, 0. That's a good place to have it. I know that I have one side that is going up the y-axis, and it's 3. And I know I have one side along the x-axis, which is a length of 6. Well, I know to be a rectangle, I have to have right angles. So I know these are 4 right angles, which means I know these are all perpendicular sides. I also know that the opposite sides are congruent. So I know this top side is 6, and I know this right side is 3. So I can actually find all of my coordinates knowing I'm starting at 0, 0. I know I can go up 3, so that would be 0, 3. And I know that this point right here would be just right 6, so this would be a 6, 0. So 0, 3 and 6, 0. M is where those two meet up, right 6, up 3, so M must be at 6, 3.
You could almost think of it as, to find M, what would your run and your rise have to be? Well, you would have to run 6, rise 3 to get to point M. Your run being 6 and your rise being 3.
All right, so now let's go ahead and do the same problem, but now we're just going to use letters, no numbers. So again, we have one vertex located at 0, 0. I do not know how long my vertical side is, but I know this vertex is at 0C, which actually gives me the length of my vertical side. I know I went up a distance of C. Whatever C is, doesn't matter. I'm going to say that that side length is C. If this side is C, then the other vertical side must be C, because we know rectangles have opposite congruent sides. For our vertex along the x-axis, I know I'm at B0. So even though I don't know the value of B, I know I went from 0 right B. So this top side must also be B. So I can now use that to deduct what point M is going to be. I have to go right B, and I have to go up C. So therefore my point M would be located at BC. All right.
This next problem, Michael, I absolutely love because it requires some logical thinking.
It really does. And I think of it sort of like translating. Where am I moving from? Where am I going to? So this time, the shape I'm giving you is a little bit more complicated because we don't just have our vertical and horizontal sides. We have a parallelogram this time. So I did keep it easy in that you have a vertex at 0, 0, and I also did give you horizontal sides. I know that this point is at 4, 0. So I can go ahead and use that to deduct what this side length is going to be. We know that that side length has to be 4. I also know that a parallelogram has opposite congruent sides, so therefore this side must also be 4. I also know that if this is at a height of 1 off the x-axis, that this one would have to be at a height of 1 because opposite sides are parallel. So if this side is going horizontal, then the top must also be going horizontal. Now to find my x point though, you have to think about where, like, it's shifted. Remember when we talked about parallelograms and rhombuses, it's almost like they're pushed over from a rectangle and a square. So what we're going to look at is right here. To get from 0, 0 to 3, 1, I would need to go up 1 and right 3. So to get to this point, you have to kind of think of that as you're from here you're going right 4, but then you're going to go up the same way you did here. So you would need to go up 1, and then you would need to go right 3 again. Well, you're starting at 4. So if I'm at 4 and I go right 3 more, you're going to be at 7. So right here we're at 0, 0, up 1, right 3 gives you 3, 1. Here we're at 4, 0, so I would need to go up 1 and right 3 more, putting me at 7, 1. All right, so now we're going to go ahead and apply this using the letters. This one's going to look a little bit more confusing, but if the one we just did made sense, then this one should make sense as well. So looking here, I know that I have a vertex at 0, 0. I know that I have a vertex at F0. So the fact that our y's did not change, the fact that that bottom side is going along the x-axis tells me that the top is also horizontal. So I actually already know this fourth vertex right here. I know the y value is going to be E because that's how high up this point is. Now, as far as how we're going to find our x coordinate, you have to think about how you got from 0 to here. Well, you're going to go up E and then right D. So from here to get to here, I would go right F, and then I need to go up E, right D. So you can kind of see that visual here. You can see right here I went up E, right D. Here I'm going right F, and then I'm going to go up E, right D. Well, the two right moves are F and D. Well, those are not like terms. So in the previous problem, I was able to simply add them together. 4 plus 3 gave me that 7. But here in this problem, I am not able to add them together because they're not like terms. So they would have to remain two separate letters, two separate terms. F plus D, they're both positive because you're going right and right. We know moving right is positive from our translation days. And then I went up E, so again, E is going to be positive because we know up is positive. And that's it.
That's it?
That's it.
Wow.
So, hopefully you're down here. I know that last one is a little bit confusing, and it's always confusing seeing letters, but I was hoping that by showing you with the numbers that the letters were a little less painful.
We'll see.
So, if you have questions, there we are. Freaking out a little bit in that picture.
So, hey, Mrs. Weichel.
Hey, what is this?
So, I'm going to have a picture for this one, but have you ever told your students lines go on forever?
I have. Same with Ray's.
Yeah, check this out. Maybe we should warn some people. They're going to get poked out there in the hallway. Get the Ray out of the way.
Thanks for joining us.
See
That was
you in
chapter 5.
See you in chapter 6.